Question 5. To ensure business continuity, a company requires an RTO, that's a recovery time objective, of 2 hours, and an RPO, recovery point objective, of 15 minutes for its critical application. Which AWS disaster recovery strategy best fits these requirements? So all 4 of our answer options are disaster recovery strategies. They are approaches to dealing with the possibility that something breaks and we need to be able to get back to a working state with it. 2 metrics are used to measure the capabilities of these solutions: RTO and RPO. Both of them are amounts of time, but what they measure differs. The recovery time objective answers the question of how long the system can be down before some irrevocable business injury is sustained. So here we're saying that this critical application can be offline for 2 hours and we're still going to be okay. The boss won't be happy, but we're not going to go out of business. The other metric is called a recovery point objective. It's also a unit of time, but what it measures is how much data we can afford to lose. If I have an application that's running, and over the course of the day, once every hour, I make a backup of that data. We make a backup at 9 in the morning, we make a backup at 10 in the morning, we make a backup at 11. One implication of that strategy is that if something goes wrong, just before I get to my next backup, I've potentially lost all the data since that last backup occurred. In this situation, my system fails at 10:45. I can restore my system and bring it back to where it was as of the 10 o'clock backup, but I didn't back up any of the data from 10 o'clock to 10:45. I was going to back up that data at 11, but I never got there. So in that case, we've lost 45 minutes of stored information that would need to be recovered from some manual process. Maybe employees can redo their work from the last 45 minutes. They won't be happy with that, but it could happen. So the question is, how much time can we afford to lose in terms of data loss? In this case, we're saying that a loss of 15 minutes of data is the maximum that this company can withstand. And we can survive the process of recreating those 15 minutes worth of business. But more than that is unacceptable. So the question is, which of our 4 strategies is going to satisfy the need to be able to accomplish those 2 goals? The backup and restore strategy is our first option, making a copy of key information and storing it somewhere trustworthy. It's a very economical solution, but would I be able to guarantee that I can turn back on everything that I lost within 2 hours? That's a little bit of a risk. A pilot light solution, option B, describes a solution where a miniature version of my solution is deployed in AWS and in the event of a failure can begin scaling up to absorb all of the demand from the failed solution. Again, we might have difficulty getting all of that done in a 2-hour period, so I think we're going to mark that one as not quite sufficient to the day either. Multi-site active-active is an interesting solution. This provides a complete redundant solution running in the cloud. Maybe I've got a solution on premises that has 15 servers and 2 databases. Well, maybe I'll run an identical solution in the cloud that is 15 servers and 2 databases. In the event of a failure in my primary solution, we'll cut over to the failover solution in the cloud, which is fully ready to take on all the work that we're doing instantly. Will that meet our requirement of 2 hours and 15 minutes? Yeah, absolutely. That's an almost, we might see that cutover complete within minutes or less. So that will accomplish the task, but note that our question wants to know which one best fits the requirements. The problem with multi-site active-active is that it is pricey. We are running a complete redundant architecture in the cloud, which means that our architecture is twice as expensive as it might otherwise be. Might we have a disaster recovery strategy that meets the requirements but is less expensive? Yes. The option of a warm standby provides that ability. Warm standby falls somewhere in between pilot light and full multi-site active-active. In a warm standby scenario, work is divided amongst the primary location and a small version of our production solution running in the cloud. And the combination of those together provides support for my application. So in the event of a failure on-prem, I'm already handling some of that traffic already in the cloud. I don't actually have a loss of continuity. The warm standby system will rapidly scale to be able to absorb all the demand created by the failed primary system. Warm standby fits our needs of a 2-hour RTO and a 15-minute RPO. Multi-site active-active and warm standby both meet our requirements. Warm standby best fits our requirements.